Today, we're diving deep, literally, into the hulls of the world's biggest ships. We're going to talk about a piece of engineering that's absolutely critical to global trade, but it's something you almost never see or even hear about, the ballast tank.
So let's just jump right in with a question that sounds like a total paradox. How on earth does a massive cargo ship, one that weighs hundreds of thousands of tons, avoid tipping over when it's completely empty? You'd think it would be most stable when it's lightest, right? Well, you'd be wrong.
So here's how we're going to break it down. First, we'll look at why an empty ship is so unstable. Then we'll get to the kind of surprising solution, water. We'll explore where all these tanks are hidden, then we'll take a tour inside one. And finally, we'll talk about why this whole hidden system is so incredibly important.
All right, so let's get to the heart of the problem. Why is a light ship actually a dangerous ship?
It really all comes down to basic physics. You see, when a ship is loaded down with heavy cargo, its center of gravity is super low, which makes it stable. But once you unload all that cargo, we're talking thousands and thousands of tons, that center of gravity shoots way up. The whole ship becomes top-heavy. It's kind of like trying to balance a pen on its tip instead of on its base. It's just asking to be knocked over by wind and waves.
So, how in the world do you fix that? Well, the answer is as brilliant as it is counterintuitive. You deliberately flood parts of the ship with thousands of tons of water.
And this is where our hero of the day comes in, the ballast tank. These are basically huge, purpose-built compartments inside the ship's hull. They're designed to do one thing really well: hold seawater. By filling them up, the crew can bring that high center of gravity all the way back down, making the ship stable and safe for its journey.
But here's the really cool part. It's not just about not tipping over. Ballast water is doing a bunch of jobs at once. Yep, it improves stability. That's number one. But it also reduces the incredible physical stress on the ship's structure. And this is huge. It keeps the propeller and the rudder deep enough in the water. If they're riding too high, you can't move and you can't steer. Simple as that.
Now, you can't just stick these tanks anywhere. Where they go is a real masterclass in naval design, and it's totally customized for what that specific ship is built to carry.
Okay, take a look at this. This is a bulk carrier, a ship that hauls stuff like grain or coal. It has this really complex system of tanks. You've got topside tanks up high, hopper tanks down low near the cargo, and those double bottom, or DB tanks, along the floor. All of these work together to manage the crazy forces from that heavy and sometimes shifting cargo.
Now compare that to a container ship. The design is a lot simpler. Because containers are stacked so neatly, the ship mainly just needs ballast tanks in the sides and, you guessed it, in that double bottom section to stay stable.
And what about a ro-ro ship, the kind that carries cars and trucks? Well, it's even simpler. Most of its stability comes from those double bottom tanks that run along the length of the ship's floor. You're probably starting to see a pattern here with that DB tank, right? It's pretty important.
But no matter the type of ship, pretty much all of them have two special tanks in common. There's the forepeak tank way up in the front, at the bow, and the aft peak tank at the very back, the stern. These are for fine-tuning the ship's trim, which is just a fancy way of saying they make sure the ship is sitting level in the water.
Okay, so we've seen where the tanks are. Now let's actually go inside the most common and probably most important one, the double bottom. That's the space between the outer skin of the ship and the floor of the cargo hold.
So when you look at a diagram like this, you might think it's just a big empty space, but it's not. It's actually a super complex web of steel. You've got these long girders running the length of the ship and these solid floors running side to side. It creates this incredibly strong honeycomb structure that gives the whole ship its strength.
And to give you a sense of the scale, just look at this. Forget the clean lines of the diagram for a second. These are gigantic cavernous spaces. The person in this photo gives you an idea of just how massive this internal structure is. This is engineering on a truly colossal scale.
So you might be wondering, how does anyone even get in there to check on things? Well, that's what a manhole is for. It's exactly what it sounds like. A small, sealed opening just big enough for a person to squeeze through for inspections and repairs.
So how do you move all that water around? On the left, you can see the real deal, a huge pipeline running through the tank. It ends in something called a bell mouth, right at the bottom, and you can see it in the diagram on the right. This shape helps powerful pumps suck water out or push it in super efficiently.
Now here's a detail that's absolutely crucial. If you're pumping thousands of tons of water into a sealed steel box, what happens to all the air that's already inside? It's got to go somewhere, right? That's what these air vents on the deck are for. They let the air rush out as water comes in, and, just as important, they let air back in when you're pumping the water out, so you don't create a vacuum and crush the tank.
Okay, but how does the crew know exactly how much water is down there? They use something called a sounding pipe. A crew member on deck, like the one you see here, literally drops a weighted tape measure down this pipe. When it hits the bottom, they pull it up, and the water line on the tape tells them the precise depth of the water in the tank.
So when you put it all together, the pipes for moving water, the vents for managing air pressure, and the sounding pipe to measure it all, what you have is a complete, elegant system designed to safely control an unbelievable amount of weight.
All right, let's zoom back out. We've been crawling around inside the steel guts of a ship, but what's the big picture here? Why does this hidden balancing act actually matter so much?
Here it is. Every single car, every container of electronics, every ton of food that crosses an ocean gets there safely because of this system. These totally unseen water-filled spaces are the silent, unsung heroes of global trade. They are the fundamental piece of the puzzle that ensures every voyage is a safe one.
And that leaves us with one last thing to think about. This whole system is designed to move seawater around the world to keep a ship safe. But if a ship sucks up water in a port in one continent and spits it out in a port on another, what else might be in that water hitching a ride across the entire planet? That's a question with some pretty huge environmental consequences, something to chew on. Thanks for joining me.